This is where we live, on a blue dot.
Uranus has had the worst reputation of all of our planets over the years. It's the strange planet. Recently, scientists have discovered a new mystery about Uranus's rings that were hidden deep within data from NASA's iconic Voyager 2 mission. What else is hidden in the records? Stay tuned till the very end to find out about this long-hidden mystery. A mysterious dust ring around Uranus was discovered in rediscovered Voyager 2 data. In January 1986, Voyager 2 flew past Uranus, discovering 10 moons and 2 rings, while becoming the first and so far only spacecraft to visit the ice giant. One of those rings, known as the Zeta Ring, has vexed astronomers ever since. They haven't been able to find it for nearly 2 decades, but thanks to amateur image processor Ian Reagan, researchers received an unexpected gift last year: a new image of Uranus's ring system, including the elusive Zeta Ring. Ian Reagan, an image processing enthusiast, wondered why there weren't more Voyager look-back images of dusty rings on Jupiter, Saturn, and Neptune. He went to the NASA Planetary Data System, or PDS archives, about a year ago to see if there were any more Uranus ring images that were previously known. He discovered 3 very faint rings not previously observed in the 35-year-old data by stacking and enhancing a large set of images using free software tools. The outermost Mui ring, which he describes as a narrow sheet of dust sandwiched between the Lambda and Delta rings, and the elusive and enigmatic Zeta ring. According to him, the latter is a broad sheet of dust discovered during the flyby in a single frame shuttered near closest approach. The first mention of a Uranian ring system appears in William Herschel's 18th century notes detailing his observations of Uranus, which said, February 22, 1789, a ring was suspected. Herschel sketched a small diagram of the ring, noting that it was a little inclined to the red. This has since been confirmed by the Keck telescope in Hawaii, at least for the V ring. In 1797, Herschel's notes were published in a Royal Society journal. The rings are rarely, if ever, mentioned in the 2 centuries between 1797 and 1977. This calls into question whether Herschel could have seen anything while hundreds of other astronomers did not. It has been claimed that Herschel accurately described the ring size in relation to Uranus, its changes as Uranus orbited the Sun, and its color. The Hubble Space Telescope discovered a pair of previously unknown rings, now known as the Outer Ring System, between 2003 and 2005, bringing the total number of known Uranian rings to 13. Uranus rings fall somewhere between the more extensive set around Saturn and the simpler systems around Jupiter and Neptune in terms of complexity. We thought we only had 2 images of this ring from Voyager 2 for a long time, said Matthew Hedman, a planetary scientist at the University of Idaho. This demonstrates there is still a lot of information encoded in the Voyager data that merits a second look. Scientists initially missed the discovery because the reddish dusty ring closest to Uranus was not visible in any individual image. Reagan had to combine a number of images to see the feature. He took hundreds of images and stacked them to create this image of the Uranian system, Hedman explained. This is the most complete view of the Zeta Ring that exists, and we didn't realize it was in Voyager data for decades. The new image, combined with the previous 2 Voyager images, provided Hedman and his colleagues with enough information to calculate the ring's distance from Uranus as approximately 23,000 miles or 37,000 kilometers above the planet, as well as its brightness. However, both of these values are puzzling. The first observations of the Zeta Ring since Voyager 2 in 2007 were collected by the Keck Observatory in Hawaii. These observations place the ring at 25,000 miles, or 40,000 kilometers above the planet, putting it slightly farther away from Uranus than the Voyager 2 observations. The trick is that the location of this ring did not match the Voyager images, Hedman said of the Keck findings. Over the course of 20 years, something had changed about this ring. However, they're still not sure what that was. And the Zeta Ring didn't just move away from the planet during the 2 decades it was unobserved. It also registered a stronger signal in the Keck observations than it did in the Voyager 2 view. It got significantly brighter, which means dust got introduced into the system somewhere along the way, Hedman explained. What exactly did that? They have no idea. Hedman proposed that Uranus was hit by a space rock that fragmented into debris and settled into the Zeta Ring, or that the changing seasons were to blame. But both are just theories. Whatever happened had to be dramatic enough to affect the rings while also slipping under the scientists' radar. In the coming years, NASA will begin planning a major mission to explore the Uranus system, but scientists won't have data from that mission for several decades. Hedman, on the other hand, pointed out that the James Webb Space Telescope had captured a stunning image of similar rings around Neptune, which were released in September. Because Uranus's rings appeared to be young, they must be constantly renewed through collisional fragments of larger bodies. According to estimates, the lifetime of a moon with the size of Puck against collisional disruption is a few billion years. A smaller satellite has a much shorter lifetime. As a result, all current inner moons and rings could be the result of the disruption of several Puck-sized satellites over the last 4.5 billion years. Every such disruption would have triggered a collisional cascade, rapidly reducing almost all large bodies to much smaller particles, including dust. The majority of mass was eventually lost, and particles survived only in positions stabilized by mutual resonances and shepherding. The source of the dust bands is less complicated. The dust has a very short lifetime, 100 to 1,000 years, and should be replenished continuously by collisions with larger ring particles, moonlets, and meteorites from outside the Uranian system. Because of their low optical depth, the parent moonlets and particles belts are invisible, while the dust is visible in forward scattered light. The particle size distribution is expected to differ from the narrow main rings and the moonlet belts that form dust bands. The main rings have bodies that range in size from centimeters to meters. The increased surface area of the material in the rings results in a high optical density in backscattered light. In contrast, the dust bands contain a small number of large particles, resulting in a low optical depth. The topic of dust in the Uranus ring system is more than just academic. With Uranus being prioritized in the most recent Planetary Science Decadal Survey, engineers must consider practical issues such as how to navigate a spacecraft safely around the Uranus system. We need to know where the dust is, and especially if it is moving away from Uranus over time, in order to find safe passage across the ring plane twice per orbit. Reagan's dusty discovery in dusty data will safeguard our future missions to Uranus. New discoveries are being made in space. More rings could be found around Uranus in the future. Let's wait and see. That's it for today, and we'll be back with new videos tomorrow. You don't want to miss out on the mesmerizing discoveries about space that this channel's got for you, so don't forget to hit the subscribe button. Take care, and see you later.